The Life Cycle of a Star by Christine Scheffler. Nebula. A cloud of gas and dust that usually consists of 70% hydrogen, 28% helium, and 2% other heavier elements. When an outside force or explosion of a nearby star, particles get pushed closer together. Gravity increases, pulls more particles, which is even more gravity. This process can repeat itself over and over again. Protostar. When there is movement in dense regions of the nebula, the movement is greater. For an example, this pool activity. The cue ball was pushed lightly and barely moved, whereas all the other balls were pushed harder and went far. The nebula starts to shrink and spin, and it begins to flatten into a disk with a lot of matter in the center. This makes a protostar. More matter is pulled into the protostar, so there is more gravitational energy. This energy gets changed into heat energy, just like the bottle pumper activity. Main sequence stage. Nuclear fusion. At 10 million degrees Celsius, nuclear fusion begins. Once nuclear fusion begins, that is the birth of a star. Nuclear fusion is a process that occurs when extremely high temperatures and high pressure cause less massive atomic nuclei to combine to form more massive nuclei. Tons of energy is released as heat and light. Smaller, less massive stars can last in this stage for hundreds of billions of years. Medium stars, like our Sun, can last for around 10 billion years. Larger, more massive stars can last in the stage for only 10 million years. Once nuclear fusion is taking place, the energy is pushing out, while gravity is pulling in at the same strength. This equilibrium keeps the star the same size as long as there is hydrogen to fuse to helium. Right now, only about 5% of hydrogen in our Sun is converted into helium. 5 billion years later, without fusion, core contracts under gravity. Contraction increases temperature. Helium core is hotter and transfers energy into thin shell of hydrogen outside the core. More fusion radiates energy. Shell expands. Red giant. Red giant. The shell expands because of fusion, energy is being released. When it expands, it gets cooler. Begins to glow with a reddish color. Helium fuses into carbon and oxygen. When fusion is done, the star enters its final stage. Planetary nebula. The star's outer gases drift away. The core heats up, expanding gases. White dwarf. Planetary nebula spreads out. Gravity causes rest of matter to collapse inward. This is called white dwarf. Shines billions of years. Hot but dim. Size of Earth. Some scientists think after they no longer shine, they become black dwarfs.